Assistant Professor Electronics and Telecommunication Engineering. My topic is LIN protocol in automotive network communications. Learning outcome: at the end of this session, a student will be able to explain feature of LIN, the architecture, frame format, comparison CAN LIN protocol, applications of LIN protocol. Content: in this LIN protocol, we have to discuss introduction part, feature of LIN protocol, LIN architecture, LIN frame format, comparison CAN and LIN protocol, advantages of LIN protocol, applications, conclusions and references. Introduction part. LIN stands for Local Interconnect Network. It is advanced form of network that has been currently used in automotive sectors. LIN communications protocol have made this so much easy with the help of the single bus bar, and this bus bar is called LIN bus bar. This bus bar is a single master or multiple slave bus that transmit data with the help of the single wire. It consists of the subsystem that based on the serial communications protocol and is invented to be used for the simple switching applications such as door locks, sunroofs, rain sensors, car seats, mirrors and steering wheels, etc. The simple LIN communications protocol bus is shown in figure 1, in which the LIN communications bus bar is controlling different part of the vehicles. LIN protocol is a serial wired communications protocol for electronic devices which consist of the one master and one or more slaves, but it does support multiple slaves. Each data consists LIN frames, and every LIN frames consist of the two pairs such as a header and response. LIN masters always send the data to the header pair, then header pair send the data to the response pair, and response pair send this either to dedicated slave or LIN masters. Figure shows LIN bus history. In 1999, LIN 1.0 released by the LIN consortium, that is BMW, VW, Audi, Volvo, Mercedes-Benz, Walchand Automotive and Motorola used LIN protocols. In next 2000 years, the LIN protocol was updated LIN 1.1 and LIN 1.2. In 2002, LIN 1.3 released, mainly changing the physical layer. In 2003, LIN 2.0 release, adding major changes that is widely used, while in 2006, LIN 2.1 specification release. In 2010, LIN 2.2a release, now widely implemented versions. In 2010 to 12, SAE standardized LIN as a SAE J2602 based on the LIN 2.0, while in 2016, CAN in automation standardized LIN as a ISO 17987 2016. Properties of the LIN protocol. First one property is the single master with the multiple slave concept. Second one, low cost silicon implementation based on the common UART SCI interface hardware and equivalent in software or as a pure state machines. Self synchronization without a quartz or ceramics resonators in the slave nodes. Next one property is deterministic signal transmission with the signal propagations time computable in advanced low cost single wire implementations. Next one property is speed up to the 20 kilobits per second. And next property is signal based applications interactions. LIN communication protocol network. As shown in diagram, in LIN network, there is a one master node and multiple slave nodes. The master node is responsible for controlling the communications on the bus, while the slave node respond to the master request. The master node roles is a control the communication on the bus, sends frame to the slave nodes, sends receive roles is a receive responses from the slave nodes. The slave nodes have the responsibility to respond to the master request. Send data to the master nodes can be configured by the master node. Every slave has a single task to perform, but all these tasks are totally controlled through master LIN bus device. The message which is a transfer from LIN protocol frame format, the message which is transferred from LIN bus device to the slave device is called message frame, and it is divided into the message header and message frame. Message header, which always send the message from master node to the slave, it consists of the three different fields such as a break, synchronizations and identifiers. Similarly, the message response, which always receive the message which is sent by the master node, it consists of the two different fields such as data and checksums. As shown in diagram, for stating communication when message is sent from the master LIN bus device to the message header. Then break field checksum number of bits this data, which comprises this data into the 13 dominant bits. Then sync field synchronize this data means it defined this data into the 55 characters and allows the slave device to the automatic set the baud rate of this data. After that, the ID field, which is final field of the message header, it provides the identifications of the each message on network, and finally decided whose slave node would be respondent on this data or message. Similarly, the data field is in message response checks this data, convert it into the 0 to 8 bytes and then send it to the slave bus. The checksum field checks the algorithm of this data and finally send this data to the slave bus. Comparison overview of CAN and LIN protocols. CAN and LIN protocols. Automotive. First parameter, automotive use, that is, a CAN is used for the networks while LIN protocol is used for the sub networks. Medium access control, multiple masters are there in CAN while single masters in the LIN protocols. Typical number of the nodes, that is, 4 to 20 nodes are in CAN protocols while in LIN protocols 2 to the 10 nodes are there. Physical layer consists of the in CAN twisted pair at 5 volt, while in case of the LIN protocol single wire at battery voltage plus ground level. Slave clock generation in case of the CAN protocols consists of the crystal or resonators, while in case of the LIN protocol it consists of the RC. Error handling, it is consists of the CRC, while in case of the LIN protocol it consists of the data checksum. Main used extensively for communications between the different issues, while LIN protocol is used for the low cost, low bandwidth and communication systems. Applications examples for the CAN, it is used for the ABS, engine control and parking assistance, while in case of the LIN protocol it is used for the power window, mirrors, door locking, light and rain sensors accessories. Advantage of the LIN protocol. LIN offers several advantages that make it an attractive choice for automotive applications. Some of the key benefits includes low cost, that is, the LIN is a low cost solution compared to the other communications protocol like CAN or FlexRay. Simple implementation, LIN has a simple architecture and is easy to implement, making it popular choice for the automotive manufacturers. Low speed data transfer, LIN operate at a relatively low speed up to the 20 kbps, which is sufficient for many automotive applications. Robustness, LIN is designed to be robust and fault tolerant, make it suitable for use in harsh automotive environment. Applications, LIN system is mostly used in advanced automotive industry, therefore it is controlling different parts of the vehicles. First one, application roof, LIN system is used at a vehicle roof for controlling their sensors such as the sunroof sensors and light control sensors. Second one is used for LIN protocol as a steering wheel, that is, it is used at vehicle steering wheel for controlling climate control sensors, wiper sensors, turning light sensors, radio and wheel lock sensors. Third one, seat, it is used vehicle seat where the position of the seat is controlled through motor and this motor is controlled through LIN system. Besides, it is also used for the controlling the occupant sensors and control panel sensor which are installed at a seat. Next one, door, it is used at a vehicle door for controlling the position of the motor which is installed with the door mirrors. Beside this, it is also used for the controlling central ECU, that is electronic control unit, windows, LIN, seat control with switch and door locks, etc. Engine and illuminations, it is also used for the controlling engine sensors such as a cooling fan, motor sensors and illumination sensor which controls the illuminations of the light. Conclusions, LIN is widely used communications protocol in automotive enabled embedded systems. Its low cost, simplicity and robustness make it an effective, attractive choice for a wide range of the automotive applications. As the automotive industry continues to evolve, the use of the LIN is expected to continue growing, driven by the increasing demand for advanced safety features, comfort systems and autonomous driving capabilities. These are the references used for the LIN protocols. Thank you.